Okay, hey Maddie and Ellie, this is 6-2. This is like the actual homework for section 6-2, but I'm gonna get them started and go through, I think, like number 3, 5, maybe 6, and some of these other ones. Okay, so just to get a little bit of an idea, like what it is again that we're doing. So 1, 2, 3 are those like summations, those Riemann sums that you're trying to find, and this kind of goes hand in hand with like doing the rectangular things because you're like adding the areas of the rectangles over and over again. So like just looking at like number 3, we're starting with 5 and going to 8. Okay, and all you're doing is plugging this into the formula and then adding them together. So if we start, we're going to plug in 5. We're going to add that to get what we get when we plug in 6. Add that to what we get when we plug in 7. Add that to what we get when we plug in 8. So there's 4 numbers that we're going to plug in.
What number are we on?
So starting with 5, we're on 3. Starting with 5, we're going to plug 5 in.
1.
And that is not 1. Close.
Oh, 5.
This is 1, so that's 5, right? 5 times 1, which is 5. Okay, now we're going to plug in 6. So we got 6 times 6 minus 4, which is 2 times 12. Yep, or 2 times 6 is 12. Okay, then we do 7. So that'll be 7 times 3, which is 21.
9. What? Oh, we're plugging in 7.
Yep, plugging in 7. Now we're plugging in 8. So that would be 8 times 4, which is 32. And we just add them all together. So you're just plugging numbers in over time. So 16 plus 53 and 69.
70?
No. I can't math. 17. Ha. Ha. 17 plus 53 is 70. There we go. Okay. Now they're doing it backwards on number 5. They don't actually want you to like figure out what that is because there's like a dot 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 in here, right? So we're not actually doing the math. We're trying to create one of these and like what the formula is, okay? So we're going to start with our sum, and we're going to define our variable. So whatever variable do you want to use? You can use k, you can use I, some of them use I, you can use n, you can use x probably. What variable would you like to use?
X. Yeah.
X? Okay, we're going to start with x, and we're going to, x equals, and then we're going to put our equation in here, okay? So taking a look at each one of these chunks every single time, which part of it is changing?
The top number.
The top number right here. Everything else stays the same except this top number, okay? So the top number starts at 1 and goes to 6. So 1 and 6. There we go. And then we just put our formula in there. So I know that the 7 is not changing. And then what goes in the inside of the parentheses here? X over 6, right?
Plus 5.
Plus 5. That's all that we're doing.
Wow.
Yeah, that's all. You're just making one of those. Not too hard, right? Okay, let's go down to like number 6. Ready? Okay.
Not really.
All right, 6 and 7 are just like doing guesstimations because we don't have an actual equation for what this thing is or this one. So 6 and 7 we're doing guesstimations. 8 you will have an actual equation, and we'll talk about how to do that one. That one's like the one that we did in the notes, right? No, we're gonna do it like tiny rectangle things. Okay, so let's do number 6 real quick. So we are doing this graph here, and first we're going to start with the left endpoints, and we're doing 4 rectangles, I believe. Approximate the area of the curve using left endpoints. Yeah, they don't say to use 4, but we're going to use 4 rectangles, okay? 4 rectangles, left endpoints, okay? So, do you see how it goes from like 0 to 4? That means each one of my rectangles is going to be like 1 unit long. So rectangle, 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 right? Okay. Now, if we're doing the left endpoints, like this rectangle is going to go up, this first rectangle is going to go up, and it's going to touch on the left side. So wherever the left side of that rectangle hits the graph, that's where I'm going to stop at. Does that make sense? How tall is that going to be?
1.
It's going to go up to 1 because it's hitting the left side right here, and then it stops. Okay. My second rectangle is going to go up to like 3. Do you see how that works? Because that's the left side, right? That's my second rectangle. Okay. My third rectangle is going to go up to like 4-ish. We'll say that that's at 4. Okay. And then the last one is going to go up to 4.5, I think. I think it's 4.5. The right side would be at 4.5. We're doing left endpoints. Left sides. So all the left sides are touching, right? Okay, so then we just have to find the area of each one of those rectangles. So I'm going to do part A is the left. So I'm just going to rewrite left so that we know for sure which side we're doing, okay? And if we do the left side, Okay, we have 4 areas that we're gonna add together. Area. Those guys. I should have written that smaller. Whatever. We have 4 areas that we're adding together. And the first rectangle, how tall is he and how big, like, each one of these is 1 unit wide,
Wait,
right?
but you can take it
One,
out,
one,
so
one.
you can take a 1 out in front.
Right, so technically we don't even have to multiply by 1. I'm just gonna do the whole area. So what's the whole area of the first rectangle? Or
One.
yeah, first rectangle is 1. Area of the second rectangle? 3.
1,
Area of the
4.
third rectangle? 4. Area of the fourth rectangle? 4.5. So we're just gonna add those together, like we would do a sum, right? 1, 3, 4, and 4.5. Technically the width is 1, so we would do like 1 times 1, and 3 times 1, and 4 times 1, and 4.5 times 1. But since it's just times 1, we don't really have to do anything for that. 1, 3, 4, 4.5. What'd you get? And we got in total
1
yet?
plus 3 plus 4 plus 4.5. 12.
12.5. 12.5. Is that an overestimate or an underestimate?
Under.
Okay, so let's put that here. It says overestimate or underestimate. This one is underestimate. Okay, now we're doing the right sides. And this one is going to, I'm going to redraw my triangle so I get to erase. Sorry if you can't. Okay, we're going to do this one. And here's my first one. If I'm doing the right sides, okay, here's the base of my first rectangle. He's going to touch on the right side. How tall is he going to be if he's touching the
3.
graph on the right side? Yeah, he's going to go all the way up to 3, right? So he's going to touch right here on the right side of the rectangle. Does that make sense? Yeah?
So
The second one is going to be 4 units tall. So this one has an area of 3. This one has an area of 4, only because each one is like 1 unit wide, right? 1 unit wide, base is 1, okay? The third rectangle, how tall is he going to be?
4.5.
4.5. Ooh, that's not the right color. 4.5. And the last rectangle is 5, you said. So 5 tall. Okay, so here's the deal. When we do the right sides, we're doing 3 plus 4 plus 4.5 plus 5, okay? So if you look at the difference between, you got what? 16.5. Okay. We talked about this yesterday, but just so that you can see, like when you're doing the left rectangles, this guy is here, and then you have these 3 middle pieces, right? Like these 3. When you're doing the right sides, they have the same 3 middle pieces, except this one is lumped off, and you're adding the 5 on because you're doing the right side ones. So that will always be the case when you're separating your rectangles, because it'll just hit. So the middle, whatever your middle ones are, those will stay the same. It's just your left side will have a left side one, and your right side will have a different right side one. Does that make sense? Okay, the right one is an overestimate. I did not spell underestimate, right? U-N-D-E-R, estimate, and overestimate. Okay, is it always over? I cannot, overestimate. Okay, is it always true that your left will be an underestimate and your right will be an overestimate?
Look at the next
If your curve goes the other direction, like this one, will look differently, right? And actually, this one will have part of it be over and part of it be under. Do you know what I'm talking about? Yeah?
No.
Yeah? Okay, so if we do the left side, is it left first?
Yeah.
Left side one first. Okay, here's my first rectangle. How tall is he going to be?
4.
4. Okay. The other one, how tall is he going to be? The next one. If he's hitting on the left side, he's going to be 5. He's going to be 5 tall because he's hitting on the left side, the left corner of my rectangle, and the left corner of my rectangle. So do you see how the first rectangle is under, but the second rectangle is over?
The next one would be 4, though.
The next one would be 4 again also, right? Because it's hitting on the left side, so this one's kind of weird. And how tall is the fourth one?
2.
2, right? Do you think that's over or under? Because you do have this part that's like you know, an under, but are these chunks that's like over? Is it going to even out to be over or under? You think?
Under.
Over.
Look at the 3 versus the 1.
What?
Oh, I meant under.
You think under? I think over.
Why?
like this area,
No, over, yeah.
this area
Over.
plus this area plus this area
Oh, yeah.
is going to be more than this one, right? So I think it's going to be over. You think? Okay.
Yeah.
So sometimes you'll be like either the left will always be over, some of the times the right will always be over. Sometimes you'll have some overs and unders depending on what part of the curve that you're looking at, okay? So figure out what all those areas are and then add them together. That is your left side. So we're saying that the left is going to be the, what did we say, over? Okay, and add all those together and then do the right side ones also.
Wait, hey.
On
the right one?
Yeah.
What about, I don't understand the, like, third triangle. Would it be 0?
What?
Or
Oh, man.
2.
Okay, so so let's do the right side ones. I'll show you what the right side ones look like. The right side one, here's the base, and he's going to be 5 tall. This is hitting on the right side, right?
Yeah.
The second one, how tall is he?
4.
4, he's hitting on the right side.
2.
Okay, next one is?
2.
2. Where's he going to hit the fourth one?
0.
0. So he'll have no height on that last one. Good call. So you really only allow 3 numbers together.
11.
If you want to put plus 0, that's fine. So that one's going to be your underestimate, right?
Mm-hmm.
Yeah. Okay, so fill those in for 7. Do you want a second to do that, or you want to go on to the next one?
What's the next one? Oh,
8,
yeah.
backside.
What's the 5th? 0.2?
What?
Yeah.
Wait, why do you have a 5th?
Shh, I'm doing 2. What's a 10th? Just 1? 0.1?
Yeah.
What are you doing?
What's 1/17th?
1 divided by 17, whatever that is.
Ah!
Are you doing some of the top ones, or what?
Mm-hmm.
What are you doing? Oh, I gotcha. 1 plus 1/2 plus 1/5 plus
Plus
1.
1/10 plus
Whatever it
1/17.
is. Yeah.
And that is, do I leave it as a icky number?
Sure. I don't know.
158 over 85?
Sure. Yep.
It's Georgia. Ah.
Okay. Ready?
For 4?
Freddy Spaghetti. Number 8. Go to the 8 side, and then we'll end the video, and then you can do the rest of them. Okay, 8 side. I will do the right ones with you, and then you do the left ones. Can you do that?
Yeah.
Can we handle it? Okay, let's talk specifics, because this one doesn't have where it exactly hits, and we need to know. So we have our function right here. We're going to end up plugging into that. Okay, let's read some stuff down below. Estimate the area between the graph of f and the x-axis. Okay, so we're saying bounded by this graph and the x-axis. So everything above that, but only between x equals 0 and x equals 2. What does that mean?
What did you do?
So x equals 0 is here, x equals 2 is here. So the area that we're trying to find is this bit right here. So it's saying like not the tails on the side, not forever going down the parabola. It's only the x-axis, those 2 things, and the parabola. So we're trying to find that area right
So
there.
you're only by half.
Okay, so they're saying using 4 rectangles. So we're going halvesies. Yeah. So,
What?
okay, we're going from 0 to 2, but we want 4 rectangles. So how wide is each one?
0.5.
0.5. So we're going halvesies, right? Each one is 0.5. Okay, so we're going to have 4 rectangles, right? And we're doing over here, we're doing the right side ones. I'm going to put right really big so I can remember which one I'm doing. Okay, right side ones. And we have 4 rectangles. So 1, 2, 3, 4. I have to do like a little visual, otherwise I'm going to forget to do one. Okay, and each one of them has a width of 0.5, right? Okay, and we learned yesterday that what we can do is we can just take that 0.5 and we can like pull it out in front, right? Can we do that?
Mm-hmm.
So all we need to put in these spots are the heights of each rectangle, right? Does that make sense? Okay, so let's go through and let's draw our rectangles with we're doing right endpoints first. Okay, so let's hit the right endpoint. So I'm going to extend these lines straight up to where it's hitting. Line straight. Why is it not doing that? Come on. I know that you want to. There we go. Line straight up. Touching. Line straight up. Ah! Whatever. We don't care. Get it out of here. Now it's doing it and line straight up. Whatever. Okay, so we're wanting it to touch on the right side, right? Because we're doing right endpoints. So if I'm going to make my rectangles, it's got to touch on this corner right here. This side here. So this is how tall my rectangle is going to be, right? It's touching over here on the right side. Touching here on the right side. Touching here on the right side. Touching here on the right side. Okay, good. Those are my right sides. Over or under? Under, I would say. So this is going to be smaller than what it actually would be. Okay, so we have to find the heights of these. Crap. How do we do that?
Oh, we plug 0.5 into the
So
thing.
find like what this coordinate point is, and the y coordinate will tell you the height of it, right? Okay, so this coordinate, what's the x coordinate of that
0.5.
dot? Is 0.5, right? It's 0.5 over, okay? And then we just have to plug it in here, which is going to be really gross, but we're going to do that and find the height of him.
0.25 plus 0.5 plus 4.
Is it? Did you do negative 0.25? the beginning?
No, because it's gonna.
No, because the negative's already there. You're only squaring this part.
Whatever.
It looks like that.
4.25.
4.25, is that what you got, Mallory, or not?
No, because I
Okay,
did wrong.
okay. So she did it right, 4.25. Okay, so that's as tall as he is. Yeah, that sounds right, 4.25, because 4 would be here, right? 4.25. So the first height, right here, is 4.25. Okay, the second height.
4.
I'm looking at this dot. Okay, so the number that we're plugging in is?
4.
Well, his
Oh,
x coordinate
1.
will be 1, right? But if you plug 1 in, you get 4. That's right. Right? Because negative 1 squared
Minus 1.
plus 1 plus 4. So this will be negative 1 plus 1 is 0
And
plus
it
4.
hits
So
on
this
the
will be 4.
line.
And it hits on the line. Right. So he has a height of 4. Yeah?
Mhm.
Okay. The third one, what's the x coordinate for the third one?
1.5.
1.5. We're going to plug 1.5 in and see what we get. Slightly above 3 maybe? Or maybe it's 3 exactly. I don't know.
3.25.
3.25. Okay. Ooh. 3.25. That's his height.
Plus 2.
And the last one? Are you sure?
Oh.
I don't think it's 2. I think it's lower than 2. So
Um,
we're gonna plug in. We're gonna plug in 2. Is that what you're saying?
No, I was saying it was 2.
That your height was 2. No, it's not 2. I don't think. You're plugging 2.
Negative 4 plus 2.
Negative 4 plus 2 plus 4.
2.
It is 2.
It is 2.
Mine doesn't look like 2, but maybe my lines are weird. Let me see. Yeah, it is hitting it 2. Huh?
13.5 times
It's hitting it 2.
0.5.
I just had it covered up. Okay, so 2.
It's 6.75.
After you take it times 0.5?
Mhm.
So 6.75. That is our underestimate. So it's going to be something bigger than, the actual area is going to be something bigger than 6.75.
So we're keeping 4.
Okay.
We're keeping 3.25.
Yeah, so you
and
should-
we're keeping 2.
You should be able to keep these 3, but then just add on your left end point rectangle, right?
Mhm.
Wait a second.
Why don't we keep 2? Why don't we keep 4.25?
No, because that's the first question.
No, because you do 0, 1 point.
Hold
0, half, 1, 1 half.
Oh, yeah, because now we're doing left and not the right. So, yeah. This is the right, so we would cross off the right one and do these guys plus a left one. Does that make sense? You need the furthest left one. So the furthest left one, we have to figure out how tall he is. So if I use left endpoints, how tall is this one going to be on the left side?
4.
4, I think. Because we would plug 0 in, right? So 0 plus these guys, and then take that times 0.5. Yeah.
7.75.
Yeah. So that's my upper estimate. So we can conclude that, you said 7.75?
Mhm.
We can conclude the actual areas between those two. Now, I asked you this yesterday, I'm going to ask you again. That range is not terribly far away, like 6.75, 7.75, that's like my actual areas between those two. How can I narrow that range?
Take the antiderivative
No.
of it.
More?
That would give me the exact one,
Rectangles.
but we don't know how to do that yet.
More
More
boxes.
rectangles, so I can do 8 rectangles instead, which means I would have to do like 0.25s wide, which would like double my work, right? That's a lot of work to do. We're not gonna actually do that, but that's how you would get a more accurate answer. doing 8 rectangles or 16 rectangles or 32 rectangles or whatever it is, right? Okay. All right, so there you go. Do the rest of those, and that's all for today. Okay? Beautiful. Goodbye, people in the video. Goodbye, Maddie and Ellie. Maybe, if I can shut it off.
Can we just
Where is my thing? There we go.